Okay, so after answering all of the questions in Plan Info, we can start off with the polygons and dimension that we have to create for OBPAL drawing. So for that, we'll go to the few components that we have to make at the starting. So if you refer to the drawing template that we have shared, each of these different type of features that you have to draw have been categorized into different sections. So the first is layers to be drawn on the site plan. Then obviously we have floor plan and elevation and all. So to start off, let's start covering the aspects that we have to make in site plan. So the very first thing that you have to make is the plot area or the plot boundary. So for that, I'll just copy the polygon from here and paste it onto my base drawing. Then I can either use the REC command if it is a normal square or rectangular plot. If it is irregular, you will use the command polyline, PL enter. Because it's a regular shape plot, I've used the command REC enter and I've just drawn the polygon for plot boundary. Then what I'll do is I'll just use the command of match, that is MA enter, and match the properties that I have brought in from the layer from drawing template and match it to the polygon that I've just created right now. Then I'll just delete the polygon. And as you can see, now we have created a polygon that is plot underscore boundary with the required color code. Now the next thing to do is to prepare the ground coverage area. So if you can see, we have two components, that is block 1 covered area with color code 140 and the other is block 1 covered area deduct with color code 140. So in case your project has an internal courtyard or any openings inside the project, you can use this layer name called block 1 covered area deduct to actually subtract that component from the entire ground coverage. So if your entire project has a value of ground coverage 100, and if there is a, what is it called, an internal courtyard or anything that has a value of 10, then after making these two components, the system will automatically deduct the value and give your net ground coverage as 90. I'll just copy this polygon from the ground coverage layer and just do the same thing, copy it here, paste it here, then and make the ground coverage polygon. And then match the property to the polygon I've just created. So whenever you are using the command PL enter for creation of any polylines, you have to close it also. So if you are using REC, the rectangle command, then because it's already a closed polygon that we are making, we don't use need to close it anymore. But obviously, if you are making a polyline, we have to use the command called pedit. That will actually close the entire polygon that we have prepared. So the command is pedit, PEDIT, then enter, then C enter for close. Enter. Now, as you can see, this polygon that we created using the command PL enter, the polyline is now closed. So whenever there in your scrutiny report, if any error comes up that has a statement similar to this polygon is not closed, you can use the pedit command to close that polygon. Now moving on, we have to create the building footprint polygon. So as you can see, it is as per occupancy type. So the color code should be the same as our project color code. So because this is a residential detached, we'll be using the color code 11. We'll do the same thing. I'll create the building footprint on top of the ground coverage only. Now we have a layer called block 1 level 0 building footprint. We'll just go to the properties part, and under more colors, there is a section called index color. We just put in the value of our project here, 11 for residential detached. So this building footprint component is done now. We have successfully created a layer name, and we have given the color code for the project. Now we have an important uh, set of polygons that we have to make, that is the setback. So inside it, you can see there are 4 different components for front, side 1, side 2. Side 1 is for left side and side 2 is for right. And then we have the rear setback. So I'll just showcase how to make one of these, and you can use the same method to create the remaining 3 also. So if you are just making the front setback, just copy the front polygon from here, paste it into your drawing. Then we can create the polygon for front setback. Now the way to make the setback polygon is, you have to make a polygon which has all its sides, sorry, all which has all its edges either falling on the building footprint or the plot boundary. There shouldn't be any edges points of the polygon, setback polygon, that is not falling in either of these components. It shouldn't be lying anywhere else. All the points should be either falling on building footprint or the plot boundary. I'll just showcase how to make it. I'll use the command polyline PL enter. I'll put my first edge on building footprint. Then it is the plot boundary. It can be anywhere. It's not required that you have to follow the exact perpendicular distance only. The system will automatically calculate each of these points from both these sides automatically. So as you can see, there are 4 edges to my polygon, and 2 of them are falling on building footprint and the other 2 is falling on plot boundary. And as I mentioned earlier, it is not required that all the sides has to be perpendicular. What the system does, it measures all the distance between the building footprint and the plot boundary. And based on all of these distance, the minimum distance will be calculated. I'll just match the property of the front setback. And I'll just delete the polygon that I brought in. So this is an example of setback that you can make. Even if your project has an irregular shape, you can use the same methodology to create all the setbacks. For example, if your project has an irregular shape, this one, in case this is your plot boundary and this is the building footprint that you have created. The way to make the front setback is, you will create a polygon and you will use the same methodology that we discussed. Each point will be either falling on the building footprint or the plot boundary. I can finish it off anywhere I want. And as you can see, I've created a polygon for front setback. Now the system will automatically calculate all the distances, infinite distances that comes up in the geometry from building footprint to the plot. And it will give the minimum setback at this value, the shortest one. So using this methodology, you can create any kind of shape you have as per the project design. And another important point that I have to make here is there shouldn't be any multiple polygons here. So if there is only one building block in your project, there shouldn't be two polygons with the same layer name called building setback for front setback. There shouldn't be two polygons. Similarly, if you have only one building block, then there shouldn't be two building footprints. There has to be only one polygon named. So if in case your project has multiple building blocks, there can be only as per the number of building blocks you can create. There has to be specifically one polygon associated to each of these building blocks. There shouldn't be more than one. Okay, now going into the next part now, open space between buildings. So this is a self-explanatory dimension that you have to give. This is the calculation to be taken for distances between different building blocks. So it is not a polygon that you have to make, it's directly a dimension that you have to put in. So to do that, I'll just copy it from here and let's see the reference document that I've shared. So you can see the dimension here. I've made a dimension called distance between block 1 and block 3. So this is block 1 and the block you are seeing, this is block 3. So I have named the layer name as distance between block 1 and 3. So similarly, there will be a dimension between distance between block 1 and 2. Distance between block 1 and 2. And similarly, we'll have another dimension between block 3 and 2. Distance between block 2 and 3. So you have to draw the dimension between each of your building blocks. This feature is not applicable if you have only one building block in your plot. Then coming on to the next component, that is the plantation tree count. Inside it, we have three different components. All of them has the same layer name, but based on the color code that you use, you are assigning different features to each of these components. If you use color code 1, it is meant for the trees that are going to be cut in your project. 2 is for the existing trees that is present already at site, and 3 is for the future trees that you are going to plant. So based on the bylaws, if you are cutting down any one tree, you have to plant 3 trees in place of it also. So you can use the color code 3 for that. If there is any green area in your project, you can use the polygon called block 1 plantation green strip with the color code 7, and you can denote that green area inside your project. Then we have the rainwater harvesting system, RWH. It has two components. One is the polygon that has to be drawn on the site plan where the rainwater system is. You have to show it as a polygon. And next to it, you have to paste this statement that is made in M text, and you will just provide the value of the capacity of your rainwater harvesting system. So if you see in the residential reference file that I showed you, this is the polygon that shows the rainwater harvesting system location, and this is the capacity it is written here. Okay, now going ahead to the next feature, that is the recharge pit. So recharge pit will have a layer name called site underscore components, and for recharge pit it is color code 1. It also has two components. One is the polygon that you have to make to showcase the recharge pit location in your site plan, and the other is the height. So, but height component you have to make only once. So, for example, if your project has 5 recharge pits, you will make 5 polygons on top of the site plan to showcase the location of those 5 recharge pits. But you'll make only one polygon, sorry, one dimension for the recharge height, recharge pit height, that you have to provide in your detailed drawing part or somewhere where in the section of the recharge pit has been shown. There you will only provide one dimension. You can refer to the apartment project to see the recharge pit location. As you can see, I provided all the recharge pit on site plan, and for section I've only provided one dimension, that is the height. Now moving ahead, we have the distance from electric lines. So this is a feature that we have in case your project is falling adjacent to an electric line, high voltage line. You can use this component to show the distance from it. So for the line component, you will be using the layer name OHEL_1. It will show the electric line that is passing adjacent to your site. To show the capacity of the line, you will use the M text and provide the value here. And then you will provide the dimension from the line, electric line, to the nearest point of your building. So these are the 3 components that you can make for distance from electric line feature. The remaining part we'll cover in the next video.